Right, let's do 2023 Maths Paper 2. Okay. Question 1. Truck drivers travel a certain distance and have a rest before traveling further. A driver kept record of the distance he traveled in kilometers on 8 trips and the amount of time he rested in minutes before he continued his journey. The information is given in the table below. Distance traveled in kilometers is X. Amount of rest time in minutes is Y. 1.1 says determine the equation of the least squares regression line for the data, meaning the line of best fits equation. So in order to do that, again, this is all calculator work. You're going to go onto your calculator. You're going to go mode, stat, a plus bx is your line of regression, right? So this is question 1.1. So y hat is equal to a plus bx. So mode, stat, a plus bx. You're going to punch in your data. In place of x is going to be the distance traveled, 180, 200, 400, 600, 170, so on and so forth. And in place of y, you're going to punch in your 20, 25 to 55, all of that drama, right? And then on the calculator, you're going to get 3 marks for this question. 1 mark is for A. A ends up being negative 23,846. B ends up being 0,227. And how we get that is after our data is in, you're going to press AC, shift 1, regression, REG, A is equal. And then again to get B, you're going to go AC, shift 1, regression, B equal. And then your final mark here is 1 mark for that, 1 mark for that, and your final mark is for putting it into your equation form. So that's minus 23,846 plus 0,227x. Equation form, right? Next question says, if a truck driver traveled 550 kilometers, predict the amount of time in minutes that he should rest before continuing his journey. So 550 kilometers, this is a distance. The distance is x. So they want you to predict the amount of time in minutes that he should rest. So they want the y value. So they're giving you the x value. They want the corresponding y value. It's simple. You're going to go to your equation y hat is equal to minus 23,846, drama there. I'm going to round that off to 85, right? Plus 0,23. And in place of x, I'm going to have 550, right? That whole thing goes in on the calculator exactly as you see it. You get 102,65. And that's the amount of minutes that he should rest if he traveled 550 kilometers. 1.3 says, this is 1.2. 1.3 says, write down the correlation coefficient for the data. So your data is still stored on your calculator. You're going to go AC shift 1, regression, and you're going to calculate R. All right? R equal, it gives you 0,98, round it off to 2 decimal places, right? That's your correlation coefficient. It's that R value. That was 1.3. Next question says, interpret your answer to question 1.3, meaning comment on the correlation coefficient. All you have to say is 0,98 is between 0,9 to 1, which is positive. First of all, this answer is positive. So you have to answer 2 parts to this. One is that it's positive, and the second is that it's very strong. So positive, strong correlation. That's what you need, right? And that's the answer to commenting on the correlation coefficient. Positive and strong. Had this answer been negative, you would say negative and strong, right? Okay, next question says, hold on. Let's erase all of that. Right. Next question says, at each stop, the truck driver spent money buying food and other refreshments. The amount spent in rands is given in the table below. 1.5.1. Calculate the mean amount of money he spent at each stop. Very simply, you're going to add all of these that plus 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 that, divided by the number of terms that you have. So it's going to end up being x bar. Remember, the mean is x bar. This is 1.5.1. X bar is equal to the sum of the data over the number of data. So when you add all of this together, it gives you 1,200 divided by the number of data elements you have, which is 8 in this case, and that gives you the mean to be 150. Then the question asks for the standard deviation. Now, the standard deviation, I'm going to do it on the calculator. We're not going to do it using the manual method. We're going to put it on the calculator. And so how we do that is you're going to go on your calculator. Sorry, let me get the calculator quickly. 1 second. Right, so on your calculator, you're going to go mode, stat, and you're going to go into variance. You're going to go into variance. Then you're going to put in your data, 100 equal, 150 equal, 130 equal, 200 equal, so on and so forth. And you're going to put it, all that data elements in. Once the data is in, you're going to press AC. You're going to go shift 1. Shift 1, and then you're going to go into number 4 variance. Right? And once you have number 4, to get standard deviation, you're going to press 3. Right? That is standard deviation. So 1.5.2, you're going to press the standard deviation. That's going to give you an answer of, give me 1 second, it gives you 50,50. That's a standard deviation. Right? Okay. The next question says, at how many stops did the driver spend an amount that was less than 1 standard deviation below the mean? So this question is always pretty simple. It's always pretty standard. All you have to do is 1.5.3, you're going to take your mean. And normally what we do is we add 1 standard deviation and subtract 1 standard deviation from the mean. Right? In this case, we're only going to use this solution. Meaning or reason being is because the question said, at how many stops did the driver spend an amount that was less than 1 standard deviation below the mean? So this is the standard deviation below the mean. So what we're going to do is we're going to take the mean amount, which is 150. We're going to subtract 1 standard deviation, which is 50,50. That gives us 99,50. And then we're going to look at the data, and we're going to look for any data element that is less than 99,50. This isn't it. No, no, no. That one works. No, no, no. That means there's only 1 standard deviation, 1 data element that is below 1 standard deviation of the mean, which means there was only 1 stop. At how many stops did the driver spend an amount that was less than 1 standard deviation below the mean? 1 stop, because there's only 1 data element less than this. All right. Okay, that was question 1. Question 2, it says, at a certain school, the staff committee wanted to determine how many glasses of water the staff members drank during a school day. All teachers present on a specific day were interviewed. The information is shown in the table below. So we have the number of glasses, which is our interval, and the number of staff members, which is our frequency. So that's how we normally get these group data tables, right? So this is the interval, this is the frequency. Now, before I even look at the questions, there's 2 columns that I always fill in. One is the cumulative frequency column. So let me just put that in. Hold on. Right, so one is the cumulative frequency column, and the other is the class midpoint. Right? So those are the 2 columns that I fill in if only the interval and the frequency was given to me. So how do we fill in cumulative frequency? The first number of frequency and the first number of cumulative frequency is always the same. Then we go diagonally, and we add diagonally. 5 plus 15 gives me 20. 20 plus 13 gives me 33. 33 plus 5 gives me 38. And 38 plus 2 gives me 40. So we add diagonally to get the cumulative frequency. Remember, the last number of cumulative frequency is always the number, total number of data elements. All right? Okay, and then to get your class midpoint, we just add these two intervals and divide it by 2. So 0 plus 2 divided by 2 is 1, 2 plus 4 divided by 2 is 3, 4 plus 6 divided by 2 is 5, 6 plus 8 divided by 2 is 7, 8 plus 10 divided by 2 is 9. And remember, your class midpoint represents the actual data element, more or less, the approximate data element, right? Okay. At this point, the question says, complete the cumulative frequency column provided in the answer book. Okay, we did that already. That's the cumulative frequency column. 2.2, how many staff members were interviewed? Again, I told you that the last number of cumulative frequency indicates the total number of data elements. In this case, the amount of staff members that were interviewed is the last number of cumulative frequency, which means that there were 40 staff members that were interviewed. Right. How many staff members drank fewer than 8 glasses of water during a school day? So this is the number of glasses of water that was drank per day. This from here, those are the people or the number of glasses that were less than 6. See, this one indicates 6 or more, between 6 to 8, because there's an equal to sign here with the 6, right? That means everything before that was less than 6, fewer than 6 glasses of water during a school day. And so when we read the number of people that drank fewer than 6, it's 13 plus 15 plus 5. 13 plus 15 plus 5. That gives us an answer of 33 staff members that drank fewer than 6 glasses of water per day. So this is 33. The next question says, the staff committee observed that K teachers were absent on the day of the interviews. It was found that half of these K teachers drank from 0 to fewer than 2, meaning in the interval between 0 to 2, half of those teachers. Glasses of water per day, while the remainder of them drank from 4 to fewer than 6, meaning in the interval between 4 and 6 glasses of water per day. When these K teachers are included in the data, the estimated mean is 4 glasses of water per staff member per day. How many teachers were absent on the day of the interviews, meaning determine K, because that was the amount of teachers absent. So let's read this slowly. It says it was found that half of these K teachers, so half of K, drank from 0 to fewer than 2. So that means that when I'm looking at this frequency table, this is 5 plus half of K, half of the amount of teachers that were absent, right? Drank between 0 to 2. And the other half, the remainder, the other half of them drank between 4 to 6. So the other half is here in the interval between 4 and 6, the other half of those K teachers. How many teachers were absent on the day of the interviews? Okay, so here's what I'm going to do. They gave me the estimated mean is 4 glasses of water per staff member per day when the K teachers are included in the data. So I'm going to do the long method of finding the mean. Right? And what we do is we know that the mean is equal to the sum of the frequency times the data all over the number of data. This is the formula for grouped data. So just keep this in mind. This is when the data is grouped, meaning given to you in table form, right? With intervals. This is the formula for mean, sum of the data over the number of data for ungrouped data. Meaning when the data is given to you loose, for example, like it was given to us in this form. Then we said this is the formula for the mean, where we just say that plus 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 that divided by the number of data elements. There's no frequency in this formula. So when we go to this question, this data is given to us in table form. It's grouped data. So we don't use this formula. We use this one. It's the sum of the frequency of the data divided by the number of data. So how do I do that? Without a calculator, this is what we're going to do. It's the sum of the frequency times the data. So the frequency times the data element, it's f times x. So what we're going to do is we're going to take the frequency times the data, plus 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 the frequency times the data, because this sigma sign stands for those pluses between everything, right? So the first thing is 1 times 5 plus a half k. Right? This is the frequency times the data, right? Plus, because sigma sign stands for you adding all of these things. Next one is 15 times 3, right? 15 times 3 or 3 times 15, either way. Plus, next one is 5. Sorry, you can't see any of this. Right. The next one is 5 times 13 plus a half k. 5 times 13 plus a half k. Hold on, let me just move all of this. Then the next one is 7 times 2. So it's plus 7 times 2. Next one is 9 times 2. Oh, sorry, this is 7 times 5. Sorry, I made a mistake there. This is a 5. This is a 5. Oh my. Okay, there. And then the last one is 9 times 2. 9 times 2. Now again, let me just pull your attention to what this actually means. It's the sum of the frequency times the data. That's how we're getting all of these, right? So this is the sigma sign, the sum of the frequency times the data. This is frequency times the data. 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 Right? Okay. And then that's all divided by the number of data elements. And in this case, I told you that the last number of the cumulative frequency is n. But remember, this is n plus k, because taking into consideration, just like we did here, we're taking into consideration the teachers that were absent. So here at the bottom, you also need to take into consideration the teachers that were absent. And then the mean for this is 4. When we take into consideration the teachers that were absent, it gives us a mean that is 4. And so now at this point, what you need to do is you need to cross multiply and you need to simplify however you can. So this is 4 into 40 plus k. This gives us just 5 plus a half k. This gives us 3 times 15 is 45. This gives us, distribute that in, right? That gives me 5 times 13 is 65 plus 5 over 2k. This gives me plus 35. This gives me plus 18. And now I'm going to add my like terms, right? A half k plus 5 over 2. That gives me 6 over 2, which is 3. Right? And then we're going to add all of this. This is gone now because you added those. This is going to be 5 plus 45 plus 65 plus 35 plus 18. Let's put that in on the calculator. 5 plus 45 plus 65 plus 35 plus 18 gives us 168. This gives me 4 times 4 is 160. And then this gives me plus 4k when you distribute in. I'm going to take that over. That gives me 4k minus 3k is k is equal to 168 minus 60, which gives me 8. And that means that there were 8 teachers that were missing if you did not understand this question, not missing, 8 teachers were absent, sorry. If you did not understand this question, can you kindly press rewind and figure out how to use this formula without the calculator? Because I know we know how to use this formula on the calculator, or the calculator applies this formula for us, but you need to also know how to use it if you cannot use the calculator, meaning there's a variable involved, so you have to actually write the entire question out. So figure out how to use that, right? Okay, question 3. It says, in the figure, L, S, and N are the vertices of a triangle having SLN equal to 90. LN intersects the x-axis at K. Got it. Okay. Calculate the length of SL. Length of SL is simple enough. It's going to be the root of x of S, which is 4 minus x of L. Hold on. Minus x of L, which is minus 4, so that's a plus 4 all squared, plus y of S, which is 5, minus y of L, which is 1 all squared. That gives us an answer. The whole thing goes in on the calculator. SL is, it said leave the answer in third form, the root of 80 or 4 the root of 5. I would go with this one. All right, that's SL. This is 4 the root of 5. Calculate the gradient of Sn. It's simple enough. We're going to use the gradient formula. Gradient of Sn is equal to y2 minus y1 over x2 minus x1. That gives us an answer of minus 8 over minus 6, which gives me 4 over 3. So the gradient of Sn here is 4 over 3. Right, next it says calculate the size of theta. Theta is the angle of inclination of Sn. The angle of inclination of Sn, the formula tan theta is equal to the gradient of Sn. Tan theta is equal to 4 over 3. To get theta alone, you're going to shift tan 4 over 3. Right? It gives you an answer of 53,13. So the angle of inclination of theta is 53,13. I'm going to put that in 53,13. 13. All right. Next question says calculate the size of LNS. Right. We did this already. I said if they're asking you for a random angle that is not an angle of inclination, an angle of inclination lies on the right-hand side of a diagonal line on the x-axis. These are angles of inclination, right? These yellow ones. Now, if they're not asking you for an angle of inclination and they're asking you for a random angle like this one, LNS, then what we do is we arc the angle we want. That's step 1. Extend the 2 arms that form the angle we want to cut the x-axis. So this is one of the arms that forms that angle. And this is another arm that forms that angle. Right. Then I said join on the x-axis to form a triangle. Now what we do is we find the angles of inclination of both of those arms. But how do we do that? We need the gradients for both of them. Now we already have this one. You have to find the gradient of this arm and then hence find its angle of inclination, which we already did. Gradient, hence angle of inclination. So now I'm going to do it for the other arm, this one. I'm going to find the gradient of that arm. Gradient of Ln is equal to y2 minus y1 over x2 minus x1. That gives me a minus 4 over 2, which gives me negative 2. Then I'm going to find its angle of inclination. And its angle of inclination is tan. Let's call this beta. Beta is equal to minus 2. Remember, this is gradient. Right? So tan beta is equal to minus 2. Beta is equal to, right, whenever the gradient is negative, remember you have to put 180 minus and then shift tan 2, not negative 2. Shift tan 2, because this 180 minus already takes care of this negative. This 180 minus that you're putting in already takes care of that negative, so you shift tan positive 2. Right? And then on the calculator, you put that in and it gives you an answer of 116,57. So this is 116,57. And then I said, get this angle using any of your geometric, not geometric, Euclidean theorems. So I'm going to get this angle. First, I'm going to get this one. This is 53,13. So I'm going to say KON is equal to 53,13. And the reason is because they are vertically opposite angles. All right, so I have this one. Now, all I have to do is say this plus this must be equal to that because it's an exterior angle of a triangle. Right. So how do I get this angle that I want? I'm going to say that this angle, because remember this plus this must be equal to that. That means this is equal to that minus that. Okay? Normal basic math there. Okay. So you can also use angles in a triangle. Get this angle by saying angles on a straight line. Then this plus that needs to add up to 180. Either one. But I'm going to go that angle in is equal to 116,57, the exterior one, minus the interior one, which is 53,13, and your reason is exterior angle of triangle. It gives you an answer of 63,43. 44. Right. And so here, this answer is 63,44. All right. Determine the equation. Hold on, let's erase all of that drama. All right. I'm going to put this in was 53,13. Put this in was 63,44. Okay. And this was 116,57. Okay. Then it says, determine the equation of the line which passes through L and is parallel to SN. So here's what I want you to do. I want you to draw a line on SN. And in your mind, you need to move this line so that it passes through L. Right. So it said, determine the equation of the line which passes through L and is parallel to SN. So this line that we just drew, hold on, this line that we just drew is parallel to SN, right? And it passes through L, right? Write down the equation of that. So what do we know about parallel lines? They share the same gradient. So the gradient of SN, we calculated it here, it's 4/3. So the gradient of SN is 4/3, which means the gradient of its parallel line is also 4/3. Right? Then you're going to go y is equal to mx plus c. You're going to put the gradient in as 4/3x plus c. And the set of coordinates you are going to use is the set of coordinates that this parallel line passes through. You can't use that, you can't use that, because none of these two sets of coordinates lies on this line. You have to use a set of coordinates that lies on the line. And the set of coordinates, they tell you what it is. It says it passes through L. Told you here that it passes through L, so you need to use L's coordinates. So you're going to go, this is 1 is equal to 4/3 into minus 4 plus c. That gives you, Lord alone knows. Okay, hold on. That gives you 19/3. So c is equal to 19/3, and therefore the equation of this parallel line is y is equal to 4/3x plus 19/3. That's the equation of this line. All right. Calculate the area of triangle LSN. LSN. Okay. Area of a triangle is a half base times perpendicular height if you have a right angle triangle. So area of triangle LSN is a half. Base and perpendicular height are the two sides that form the 90-degree, i.e. that and that, right? So SL times LN in any order, it doesn't matter because you're multiplying. SL times LN, right? Let's figure out what those distances are. SL, we already calculated. It's 4 the root of 5. So it's a half into 4 the root of 5, and ln we don't have. So ln, let's calculate its distance. ln is equal to the root of x of L, which is minus 4, minus x of n, which is plus 4, because it's minus 2, all squared, plus y of L, which is 1, minus y of n, minus 3, that's plus 3, all squared. I'm going to put that in on the calculator. It gives us an answer of 2 the root of 5. So this is times 2 the root of 5, and this whole thing will go in on the calculator to get the area of triangle LSN, and it gives us 20 units squared. All right, so the area here is 20 units squared. All right, calculate the coordinates of point P, which is equidistant from L, S, and N. Okay. So 2 things here. There's quite a few ways, actually, you could have done this question. You could have went the very long method, because equidistant means obviously equal distance, which means that if P is equidistant from L, S, and N, that means PL is equal to PS is equal to PN. Then you could use this as a formula, say PL is equal to PS, get 2 equations, because there's 2 unknowns in terms of x and y, and then the second equation, this would have been equation 1, you could have went PS is equal to PN. Sub everything in, get equation 2, solve those 2 equations simultaneously, right? However, that's very long. So there is another method to do it. And here's the other method, right? If you have a right angle triangle, right? And you wrap a circle around that right angle triangle. For example, oh my, that's not a circle. Someone help. That's still not a circle. Okay. Okay, more or less like that, right? If you wrap a circle around this right angle triangle, automatically that means that this line, which is the hypotenuse of that right angle triangle, is the diameter of that circle. Because of the theorem that states the diameter of a circle will subtend a 90-degree angle at the circumference, right? So that hypotenuse of that triangle is the diameter of the circle. And so if they are talking about P being equidistant from S, L, and N, then naturally P should lie on the diameter of the circle and be the center of the circle, because the only way that P would be equidistant from all 3 of those points is if it's the center, and these distances are radii. Because that's the only way it would be equidistant, because all radii are equal. Okay, so I'm going to say that one more time. If you have a right angle triangle and you wrap a circle around that right angle triangle, the hypotenuse of that right angle triangle will be the diameter of the circle that you just wrapped around it. And now they're talking about a point P, and point P is equidistant from 3 points that lie on the circumference of the circle you just created. Then the only way that that P, or that set of coordinates, will be equidistant from those points is if that P coordinates, or that set of coordinates for P, is the center of the circle. Because then it would be radii. That's the only way they would be equidistant. Okay, so I hope that made sense. And so if they are equidistant, what was the question? I forgot. Okay, calculate the coordinates of P, which is equidistant. Hold on. The coordinate, okay, what the heck is happening here? Right, okay. So that means P is the center of the circle. And to get the center here, it's quite simple. All you have to do now is find the midpoint of SN. And so if you find the midpoint of SN, because remember SN is a straight line, it's the diameter of the circle, right? And so we're going to find the midpoint of that. So we're going x of P is equal to x of S, which is 4, plus x of N, which is plus minus 2, all over 2. That gives me 2 over 2, which is 1. And we go y of P is equal to y of S plus y of N, all over 2, which gives me 2 over 2, which is 1. And so P's coordinates is 1 and 1. I hope that made sense to you guys. Okay, and the last question here. So this was P's coordinates, which is 1 and 1. Calculate the size of LPS. LPS. Okay, keeping in mind this angle, right? I just want to erase this. LPS. I'm going to put in this angle. I'm going to put in this line. LPS. Right, okay. Keeping in mind that angle LNS was 63,44. 63,44. Right, this is a Euclidean geometry problem. It says calculate the size of LPS. LPS is this angle. Right, so now look at it nicely from a Euclidean geometry, circle grade 11 Euclidean geometry perspective. LPS is the angle at center. The angle at that center is subtended from S and L. But S and L, they also subtend this angle at the circumference. So this is the angle at center is 2 times the angle at circumference as long as it is subtended by the same arc or chord. Right? So it's subtended from LS. Both the angle at the center and the angle at the circumference, they are both subtended by LS. And you can see that if you trace them back. You can see that if you trace back this angle, it comes from S and L. And you can see that if you trace back this angle, let's do that in a different color. If you trace back this angle also, it will come from L and S. And so that's angle at center 2 times angle at circumference. And so to get the angle LBS, it's going to be 2 times angle LNS. And you're going to give your reason angle at center equal 2 times angle at circumference. Right, so that gives you 2 into, what on earth was that? 63,44. 63,44. And then we're going to punch that in. Give me a second. It gives you 126,88. All right, and that was question 3. That was actually a nice question. I hope you understood it. If not, press rewind and go over it again. Okay, question 4. In the diagram, the circle with center O has the equation x squared plus y squared is equal to 20, which automatically means that the center is at the origin when the equation is given in that form. So your center is at 0 and 0. G, which is t and 0, is the center of the larger circle. A common tangent touches the circle at D and F respectively, such that D lies in the fourth quadrant. D, which is P and minus 2. Okay. Okay, right. Given that D is P and minus 2 lies on the smaller circle, show that P is equal to 4. So if this set of coordinates lies on this circle and I have the equation of that circle, then it's a simple matter of substitution in. The equation of the smaller circle was x squared plus y squared is equal to 20. And so I'm going to take D's coordinates, I'm going to put it in place of x and y, and I'm going to solve for the only unknown, which is going to be P. So this is P squared plus minus 2 all squared is equal to 20. That's P squared is equal to 20 minus 4. 20, this is positive 4 on that side. So if we take it over, it's going to be negative 4. That gives me p squared is equal to 16. Square root, don't forget your plus minus. Your answer is p is equal to 4, or p is not equal to negative 4 because D's x value is on the positive side of the x-axis. So it's got to be that positive value, right? So cancel out the solution. And so you showed that p is equal to 4. Okay, so the set of coordinates here is 4 and minus 2. All right. E, which is 6 and 2, is the midpoint of DF. So E, which is 6 and 2, is the midpoint of DF. Determine the coordinates of F. That's a simple midpoint formula. You're going x of E is equal to x of F plus x of D all over 2. And now you're going to sub in. So x of E is 6. X of F is what I'm looking for. X of D is 4. This is all over 2. Cross multiply. 6 times 2 gives you 12 is equal to x plus 4. Take that 4 over. It gives you x is equal to 8. So F's x coordinate is 8. And then we're going to do the same thing for y. It's y of E is equal to y of F plus y of D all over 2. That's a y, that's a y, that's a y. This all goes away. Right. We have y of E to be 2. Y of F is what I'm looking for. Y of D is minus 2 all over 2. Cross multiply. That's 2 times 2 gives me 4 is equal to y minus 2. Take that minus 2 over. It gives me y is equal to 6. So the corresponding y coordinate of F is 6. All right. So F's coordinates here was 8 and 6. All right. Next question. It says, determine the equation of the common tangent df in the form y is equal to mx plus c. They want the equation of the straight line. Remember, we need the gradient and a set of coordinates. It's as simple as that. We're going to go gradient of that line. You can use any of these two, right? I'm going to go gradient of whatever, it doesn't matter. I'm going this one, these two. So y2 minus y1 over x2 minus x1. That gives me 6 minus 2, which is 4 over 2, which gives me 2. So the gradient of that line is 2. And then we're going y is equal to mx plus c. This is y is equal to m is 2x plus c. I need a set of coordinates in place of x and y to solve for c. Any set, we're going to go with the 6 and 2 again. It's going to give me 2 is equal to 2 into 6 plus c. That gives me 2 is equal to 12 plus c. Take that 12 over. It gives me minus 10 is equal to c. And so therefore the equation of this tangent is y is equal to 2x minus 10. Let's put that in. That's y is equal to 2x minus 10. All right. The next question says, calculate the value of t, show all working. Calculate the value of t. Okay, hold on. So multiple different ways to do this, but I'm going to go with the easiest one, right? First of all, we know that this is a radius perpendicular to a tangent, like that. So whatever the gradient is of this line, this one will be its reciprocal with the opposite sign. And so the gradient of this tangent is 2. And so therefore the gradient of the radius will be minus a half. Opposite sign to this, and the reciprocal of 2 over 1 is 1 over 2, right? And so the gradient of the radius is minus a half. So that's what I'm first going to say. I'm going to say gradient of the radius is minus a half because tan perpendicular to radius. Give the Euclidean geometry reason. And then you're going y is equal to mx plus c. Your m is minus a half x plus c. You're going to use any set of coordinates. I'm going to use 8 and 6 because that's the set of coordinates that lies on my circle. Well, not on my circle. I don't really care about that. I care about it lying on my radius, sorry. It needs to lie on the radius. So this is the set, and that's the set that lies on the radius. Obviously, I can't use this one because there's a missing variable, so I'm going to use 8 and 6. That gives me 6 is equal to minus a half into 8 plus c. That gives me 6 is equal to minus 4 plus c. Take that minus 4 over, c is equal to 10. And so your equation for this graph is, what question was this? Oh, okay. So the equation of this graph is y is equal to, of this graph, the radius is y is equal to minus a half x plus 10. Right. Now at this point, t or g is the x-intercept of this graph, of the radius. Right? G is the x-intercept of the radius. And so in order for me to get t's value, I'm just going to sub this set of coordinates in place of x and y and solve for the unknown. So this is going to give me 0 is equal to minus a half t plus 10. I'm going to take that over. It's a half t is equal to 10 times both sides by 2. So either divide both sides by a half or times to 2. Obviously, the smarter thing is to times both sides by 2. So I'm going to times this to 2 times that to 2. That gives me t is equal to 20. And so this g's coordinates is 20 and 0. Okay, I hope that made sense. All right, I need a break. Give me a second. G. Oh, it just asked you for t, so t is equal to 20. All right, pause. Okay, so question 4.5 says, determine the equation of the largest circle in the form ax squared plus by squared plus cx plus dy plus e is equal to 0. I'm going to start off with the standard form of the big circle, which is x minus a all squared plus y minus b all squared is equal to r squared, which gives me x minus the x coordinate of my turning point, my center, x minus 20 all squared plus y minus 0 all squared is equal to r squared, right? I also need to figure out what r squared is. So I need a set of coordinates that lies on my big circle to sub in place of x and y and solve for r. And so that is 8 all squared. This set of coordinates lies on my circle. So it's 8 minus 20 all squared plus 6 minus 0 all squared is equal to r squared. That gives me an answer of, no clue. Give me 1 second. That gives me an answer of r squared to be 180. Right? And so my equation is x minus 20 all squared plus y minus 0 all squared is just y squared. Right? Is equal to 180. R squared is 180. I'm going to square out this binomial. You can also write the bracket twice and FOIL it out. But I'm going to go first times first. First times last times 2, that's minus 40x. And last times last is plus 400 plus y squared is equal to 180. I need to get it into this form that they wanted it. So just hold on. They wanted it in ax squared. So the x squared first plus by squared, and that means the y squared next. That one's gone, that one's gone. Plus cx, which is a minus 40x, plus dy, there is no single y, plus e. So 400 minus this 180 gives me 220 is equal to 0. And so there it is in the form that they wanted it. All right. Simple. Remember, you needed to start with this basic formula of a circle whose center is not at the origin. This is the general formula of a circle whose center is not at the origin, keeping in mind that A and B are the centers, X and Y coordinates. All right, and if they want it in that in this form, then you just get rid of the brackets. If they wanted it in this form, just get rid of the brackets. Okay. So I'm just going to write this here. This is x squared plus y squared minus 40x plus 220 is equal to 0. Okay, the one thing I want to get from here is that r squared was 180, which means r was the root of that, the root of 180. We don't need this here, but I'm just doing it for future reference. The root of 180 is 6 the root of 5. So the radius of the big circle is 6 the root of 5. The radius of the small circle is the root of 20, which is 2 the root of 5. Okay, all right. Let's look at the next question. It says 4.6, the smaller circle must be translated by k units along the x-axis to touch the larger circle internally. Calculate the possible values of k, meaning how many units does the graph or the circle, a small circle, have to move so that it touches the bigger circle internally. And so, oh no, I'm going to do this by just brute force. Okay, so this is the smaller circle. In order for the smaller circle to touch the bigger circle internally, it needs to move. This point needs to lie on this point, right? So it needs to move like that. That will touch it internally, where this point now move to that point. So the total distance that it has to move is made up of this, right? Now, in order to figure out what that distance is, this is why I'm saying I'm going to do it by brute force. I'm just going to figure out randomly how I can find that distance. So the first thing is this point is the x-intercept of the bigger circle. This point is the x-intercept. It's one of the x-intercepts of the bigger circle. So I'm first going to find that, and then I'm going to explain why I'm doing that later. So first I'm going to find the x-intercepts of the bigger circle. Here's the bigger circle's equation. All right. I'm going to find the x-intercept by making y equal to 0. So this is x squared plus 0 squared minus 40x plus 220 is equal to 0. That gives me x squared minus 40x plus 220 is equal to 0. And my x-intercepts end up being, I'm just going to get what they are. 1 second, let me punch that in. 20 plus 6 the root of 5 is the first one. And 20 minus 6 the root of 5 is the second one. 20 plus 6 the root of 5 is more or less 33 comma approximately 33 comma 42, and this one is approximately 6,58. Right. So this is the one closer to the origin, and this is the one further away from the origin. So I'm just going to put that in quickly, that this set of coordinates right here, or the x-intercept right there, that distance is 6,58. 6,58, and this is 33,42. Right. This is also known as 20 plus 6 the root of 5. 20 plus 6 the root of 5. Just when you put this in and you on your calculator and you press SD, it gives you this value. I just wanted to see more or less what the value was. And this one is 20 minus 6 the root of 5. And when you put that in, it gives you that amount. Okay, so here's the thing. We established that in order for the smaller circle to touch the bigger circle internally, it's got to move this distance, right? So from this point to this point. Now, how do I figure out what that distance is? In my brain, it's telling me that it's this distance plus this distance. Now, I know what this distance is. It's 6,58. This distance from here to here is 6,58 because that's the x-intercept of the bigger circle. Because this set of coordinates here is 6,58, meaning from the origin to this point, from the origin to that point is 6,58, right? Because it's the x-intercept of the bigger circle. So I know that this distance is 6,58, and this distance is the length of the radius of the smaller circle. So from the center to the circumference, that's the length of the radius of the smaller circle, which means that that is the length of the radius of the smaller circle was 2 the root of 5. So this is 2 the root of 5. And so to get this total pink distance, it's that plus that. Now keeping in mind that this is, when written in third form, 20 minus 6 the root of 5. So K is equal to 2 the root of 5 plus 20 minus 6 the root of 5. So when we put that in, it meaning this plus this, right? That's the total distance. So 2 the root of 5 plus 20 minus 6 the root of 5 gives me an answer of 20 minus 4 the root of 5. And if we SD that, it gives me an approximate 11, let's go round off to 2 decimal places. That's 11,06. Okay, that's the first scenario. This is when the smaller circle touches the bigger circle on the left-hand side. But then there's another scenario also. The other scenario is this. Watch. Right? We have, I'm not going to erase that part, right? I'm going to leave this alone because I need that point. We have the smaller circle. Right. The smaller circle can also touch the circle internally here. Meaning that this point on the circle can touch this point on the bigger circle. So this point on the smaller circle can touch this point on the bigger circle, and it's still touching the bigger circle internally. So that means it also needs to move a total of this distance. Now, how do we form that distance? That's also the question. And so to me, I'm thinking, how do I calculate what that pink distance is? The first thing that's coming to my mind is that it's this total distance, which is the diameter of the circle, plus this distance. And I need to figure out what that small distance is. So I'm going to say that to get the total movement, the value of K, it needs to move from this point to this point. That means it needs to move a total of this distance. And this distance to me is made up of this total distance plus this small distance. So this big one is not difficult for me to find because that is the diameter of the bigger circle. And the diameter of the bigger circle is made up of 2 times its radius. So this distance is very easy for me to find. It's the diameter of the biggest circle, and the diameter is 2 times the radius. And the radius of the biggest circle, we figured it out here, it's 6 the root of 5. So to get this blue distance here, this is 2 into 6 the root of 5, which gives me 12 the root of 5, right? That's just this distance. That's 12 the root of 5, right? So K is going to be equal to 12 the root of 5 plus, which is this distance, plus this small distance. And that's what I need to figure out right now. So to get that small distance, this is what I'm going to do. I know that this total distance is 6,58. It's 20 minus 6 the root of 5. Remember, these two things are the same thing, right? One is just in third form and one is in decimal form. So I know, because this is the x-intercept of the bigger circle, the distance from 0 to there is 6,58. And so to get this small part, I'm just going to subtract the length of the radius of the smaller circle from this big part to get this small part. So I'm going to say that again. I know that this big part from 0 to the x-intercept of the big circle, I already calculated it. It's 6,58. I want this part. I don't have it. But I can get it by saying it's 6,58, which is the whole distance, minus this small part to give me that part. And this small part is the length of the radius of the small circle. It's 2 the root of 5. This is the length of the radius of the smaller circle, 2 the root of 5. So it's 6,58 minus 2 the root of 5 to give me this part. So I'm first going to calculate that part, right? I'm going to say, I don't want to call it 6 the root of 6,58. I want to call it 20 minus 6 the root of 5 because I need the most accurate answer, and third form is going to give me the most accurate answer. So instead of using this, I'm using this. But again, keep in mind, it's the same thing. So it's this distance minus 2 the root of 5 to give me this distance. So I'm going to say, let's call this M, right? dm. From here, d to m is equal to, I hope nothing else in the sum was called m. It wasn't. Okay, so dm is equal to the big distance minus the small distance, which is 20 minus 6 the root of 5 minus 2 the root of 5. That's going to give me dm, which is 20 minus 8 the root of 5. Right. That gives me this little distance here. Right? And I said that this distance, the pink distance, the whole pink distance, is made up of this plus dm. And so this full distance we already established was 12 the root of 5 plus dm, which ended up being 20 minus 8 the root of 5. 20 minus 8 the root of 5 is this small distance here between these two points, right? And that was dm, 20 minus 8 the root of 5. That gives you an answer here of 20 plus 4 the root of 5. And if we put this in on the calculator in ST, 20 plus 4 the root of 5, that gives me 28,94. And so that's the total distance that the circle moved in order to touch the big circle on the right-hand side. Okay, so this is your first answer for K. This is your second answer for K. Or the other way around. Either way, doesn't matter. All right, that was question 4. It wasn't too bad. Let's go on to general trigonometry. All right, question 5. Given sine beta is equal to 1 over 3, where beta lies between 90 and 270. Again, we're first going to draw a Cartesian plane, right? Right, so sine is equal to a positive number on the side, right? Remember to get this in the form function angle equals number, and then you can see if it's positive or negative. In this case, it's positive. Sine is positive in 1 and 2, quadrant 1 and 2. This is 0, 90, 180, 270, 360. Beta lies between 90 and 270. 90 and 270 is there and there. So that one and that one. And so wherever you see the double tick, that's where you're going to draw your diagram. So in this case, it's in the second quadrant. Your terminal arm, drop a perpendicular to the x-axis. And let's fill that in. This is the angle for beta. It exists outside of the triangle in this case, but you're still going to picture it as if it's there. All right, okay. This says sine is equal to 1 over 3. Remember, sine is opposite over hypotenuse. So the hypotenuse is the side opposite the 90 degrees. So that's 3. And opposite is there. It's 1. So this is 1. To get the third side, you're going to use the theorem of Pythagoras. We start hypotenuse squared is equal to 1 squared plus adjacent squared. Don't forget your reason of Pythagoras. That gives me 9. This is 1. If I take it over, it's a minus 1 is equal to adjacent squared. That gives me 8 is equal to adjacent squared. Square root. Don't forget your plus minus. In this case, your answer is negative the root of 8. And the reason it's negative the root of 8 is because it's on the negative side of the x-axis. Okay. Right, that's that. Now, we're going to answer the question. It says, without using a calculator, determine each of the following. As long as this angle matches the angle on the diagram, you can pull from the diagram. Cos is adjacent over hypotenuse. Adjacent to this angle is the one lying next to it, which is minus the root of 8 over hypotenuse, which is 3. So we have minus the root of 8 over 3. You can also write that as minus 2 the root of 2 over 3, because this simplified is 2 the root of 2. I'm actually going to change that, right? This is 2 the root of 2. Okay, sine 2b. This angle does not match the angle on your diagram, so you first need to make sure that it does. This is the sine double angle. It becomes 2 sine beta cos beta. Now these angles match the angle on your diagram, and so this is going to be 2 sine beta, the whole sine beta. What I've seen is people replace just the sine with opposite over hypotenuse. That doesn't make any sense because sine, cos, and tan don't exist in math without its angle. So the whole thing, the sine with its angle, must be replaced with opposite over hypotenuse. Same thing for cos. You don't just replace this part and have adjacent over hypotenuse with a beta outside. It makes no sense. So what you need to do is you need to replace the whole cos beta, the cos with its angle, with adjacent over hypotenuse. We're now going to pull from the diagram. Opposite is 1. Hypotenuse is 3. Opposite over hypotenuse. 1 over 3. And adjacent of hypotenuse is minus 2 the root of 2 all over 3. That can go in on the calculator. No. They won't give you a hard time for that. But you can just say top times top times top over, this is over 1, bottom times bottom times bottom. That's what you can do. So we're going to do that quickly. It's minus 2 times 2. That gives you minus 4 the root of 2 all over 3 times 3, which is 9. That's the answer to 5.1.2. The next one has cos 450 minus beta. This angle does not match the angle on the diagram, so you need to manipulate it. First of all, whenever you see an angle bigger than 360, you're going to subtract 360 until you get 360 or less. So on your calculator, you're going 450 minus 360. It gives you 90. So we rewrite the sum as cos 90 minus beta. Now we can reduce this because this angle still doesn't match the angle on my diagram. In the 90 minus quadrant, cos is positive. This is the 90 minus quadrant, the first quadrant. Everything is positive in that quadrant. But because you are reducing with 90, that cos is going to change to a sine. If you reduce with anything on the y-axis, sine changes to cos, cos to sine, tan to cot. So we're reducing with 90 minus, that's a positive sine beta. Now the angle matches the angle from the Cartesian plane. That's O over H. Opposite is 1. Hypotenuse is 3. And that's your answer. All right. I hope that made sense. Right. Looking at 5.2. Given cos to the power 4x plus sine squared x times cos squared x, all over 1 plus sine x, an identity. This is an identity. Prove that all of that drama is equal to 1 minus sine x. So again, I think one of the things that confuse matriculants when it comes to trigonometry and proving identities is ignoring your algebra, your basic math, just because you see a sine, cos, or tan. And so What I'm going to do is I'm going to picture this as x to the power 4 plus y squared times x squared. And so that means there's a common factor. The common factor is cos squared x. So if I take out 2 cos's from here, that means there's 2 left. So it's a cos squared x left there. And if I took out cos squared from here, then only sine squared x is left. So this is plus sine squared x. This is all over 1 plus sine x. Remember, to prove an identity, you only work with one side, make it look like the other, right? Okay. In this bracket, this is a grade 11 identity. Sine squared plus cos squared or cos squared plus sine squared is equal to 1 numerically. So we have cos squared x, show the 1. This is all over 1 plus sine x. Cos squared x times 1, anything times 1 is the same thing. So it's just a cos squared x all over 1 plus sine x. This also is a grade 11 identity. It's 1 minus sine squared x. Cos squared x is equal to 1 minus sine squared x. You can't do anything in trigonometry if you don't know your theory. You need to know your identities like the back of your hand. So this is 1 minus sine squared x all over 1 plus sine x. Remember, that's equal to that. Right? Then this is the difference of 2 squares. You're going to open up a double bracket. This stays the same. Difference of 2 squares, square root of the first plus minus square root of the last. So square root of the first is 1 and 1 plus minus square root of the last is sine x and sine x. What cancels is this 1 plus sine x with that 1 plus sine x, and you're left with 1 minus sine x, which is equal to your right-hand side of 1 minus sine x. Right. Okay. That one's done. And then it says, for what value or values of x in the interval between 0 to 360 is all of this drama undefined? Undefined is you taking the denominator exactly as is and making it equal to 0. So any denominator you find, which is this, in this case, you're going to take it, you're going to make it equal to 0. So we're going to have we're going to say for undefined. For undefined, the denominator, whatever it may look like, must be equal to 0. And then you're going to solve for x. This is going to give me sine x is equal to minus 1, which is a special case. The special case is minus 1. Sine is equal to minus 1, 90, 180, 270. It's x is equal to 270 plus 360k. Plus 360k. All right? That is the special case of sine x is equal to minus 1. But now at this point, you can't stop here because they said, what are the values of x? Solve for x, right? This is just the general solution. So what you need to do is you need to replace k with minus 2, then minus 1, then 0, then 1, then 2, and get all the solutions that lie between 0 and 360. So you're going to take 270 on your calculator. You're going to go plus 360. You're going to open a bracket. You're going to put minus 2. Look at that answer. See if that answer is between 0 and 360. If not, then you go back on your calculator. You put minus 1. You put it in on your calculator. You check if the answer produces an answer that is between 0 and 360. If not, then you go back. You replace the 1 with 0. Now you did that one. You did that one. You're at 0. You're going to put it on a calculator. You're going to get an answer. See if the answer belongs or exists within 0 to 360. In this case, it does. All right? Because this is 0. So that gives you 270 plus 0, which is 270. And 270 lies between 0 and 360. So that's one of your solutions. Then you're going to use 1 in place of k. That's too big. And 2 is also going to be too big. So 1, when you put it in on the calculator, this total solution will not lie between 0 and 360. And even if you take 2 and you put it in place of k and you punch it in on the calculator, that solution will not lie between 0 and 360. And so the answer is just x is equal to 270. All right. Okay. And then it says, write down the minimum value of the function defined by all of that drama. Now, we simplified this to this, right? And I told you in one of the previous question papers, that whenever they ask you for minimum and maximum in trigs, you have to simplify whatever they are giving you to look like a trig function equation. So it has to look like a trig graphs equation. So you need to simplify this that they're asking you for the minimum and maximum of. You have to simplify it so much that it gives you the format of a trigonometric function graph. Function, right? So this is what you're going to do. This we've already simplified to give us 1 minus sine x. Right? So I know that y, if it's equal to this, then y must also be equal to this because I simplified this drama to give me that. We proved that this whole thing is equal to that. So I know that if y is equal to this, then y must also equal to that. And so now when I look at this, this is a trig graph. And how does it, I'm going to put it in standard form where the function is in front and that mean value is at the back. So this is minus sine x plus 1. And so now, when you think of it in terms of a graph, and you want the minimum value of this graph, then what you need to think about is where the mean is and what the amplitude is. So the mean is at positive 1, right? It's at positive 1. Right? And the amplitude is 1. It's minus 1. So it's 1 up and 1 down from the mean. So 1 up from the mean is 2, and 1 down from the mean is 0. This negative, there's a minus 1 here, by the way. This negative just tells us if we're going to start at the bottom or the top first, or go up or down first, right? But we care about the number more than we do the sign when it comes to this question. And so the amplitude is 1, which means 1 up and 1 down from the mean. And so that means that this graph, however it looks, is always going to lie between 0 and 2. And so the minimum value that this graph reaches, it doesn't go below 0. And so the minimum value of this graph is 0. I hope that made sense. Okay. Right, okay, that's a proof. I refuse to do proofs. You need to go and learn it. Hence or otherwise determine the general solution of the equation that. Okay, so simple enough. We have sine 48 cos x minus cos 48 sine x is equal to cos 2x. At this point, I need to reduce this. It's the psi, that's the sine compound angle, psi-co, right? So we're going sine 48 minus x is equal to cos 2x. At this point, this is one of the types of general solution that I gave you from the notes. I gave you all the different ways that the general solution can come out. I did miss out the way that the trials gave it to you, but we'll add that to the notes afterwards, right? But right now, this is one of the ways that general solution comes out at this point, where you have a sine is equal to a cos. The coefficients are the same, but the angles are different. And so I said create same function is equal to same function. How? You leave the complicated angle alone and you change this. And how do I change it? I immediately change it to sine and then a reduction of 90 minus 2x. Because remember, you can't go cos 90 minus 2x. Because cos 90 minus 2x is equal to, if you reduce this, it becomes sine 2x. And sine 2x was not part of my sum. So when you change it, it's you rewriting the sum without affecting the numerical value of the sum. This and this is exactly the same thing. If you were to reduce this, it would give you the question. So you're just writing the question a different way, but numerically it has to be the same. And then you don't reduce after this. That means you're just going backwards, right? So you don't reduce, you keep that as is. You have same function is equal to same function. Now you write the first angle twice. You go 48 minus x is equal to, or 48 minus x is equal to. Right? On the other side, sine is positive. Sine is positive in which two quadrants? The 0 plus quadrant and the 180 minus quadrant. So This is 0 plus, this is 180 minus. Those are the two quadrants where sign is positive, because this is a positive sign, right? And then you bring down your reference angle, and your reference angle is this one that you didn't use. It can't be this one, because you already wrote this one twice, right? So your reference angle is the second one that you didn't yet use. It's 90 minus 2x. 90 minus 2x, keep a bracket, right? Because there's a minus there. There wasn't a minus there, so I didn't need a bracket for this, right? Okay, so keep a bracket whenever you're subtracting more than one term. At the end, because it's sine of cos, you add 360k. And now you're just going to simplify this. So this is going to give you minus x plus 2x on that other side gives you an x. And this is 90 minus 48 gives you 42 plus 360k. That's the first one. Second one is you're going to get rid of that bracket. That's 48 minus x is equal to 180 minus 90 plus 2x plus 360k. Right? That gives you minus x minus 2x on that side gives you minus 3x is equal to 180 minus 90 minus 48 gives me a 42. Let me just see. Gives me a 42. All right? It gives me, yeah. And then plus 360k. And then you're going to divide right through here by negative 3. So x is equal to 42 divided by minus 3 gives me minus 14. 360 divided by minus 3 gives me minus 120k. Don't forget k is an element of integers. That's how you have to end the general solution, and that's your answer for that one. All right, that was question 5.3.2, the general solution. All right, okay. And the last question here of question 5, it says simplify sine 3x plus sine x to all over cos 2x plus 1 to a single trigonometric ratio. Sine 3x, I told you if you see this, you need to break it up. All right? You're going to break this up into 2x plus x. So it's sine 2x plus x plus this sine x here at the back. All over. We're going to leave this cos double angle until we know what to change it into. But it is occurring with a 1. But I'm going to leave it for now. Right? This is going to be a psycho, a sine compound angle. You're going sine 2x psycho cos x plus cos 2x sine x plus sine x. That's all over cos 2x plus 1. Right. At this point, I'm going to expand the sine double angle. So it's going to give me just this part, gives me 2 sine x cos x, right? And then I'm going to bring down this cos x, which I can then write this as 1 cos to the power 2x. And so that's what I'm going to do. I'm going to write this as cos squared x plus cos 2x sine x plus sine x. This is all over cos 2x plus 1. Now on top, I can see a common factor. The common factor is sine x. Remember, I couldn't take out sine x here because all the angles did not match. That one was 2x, that one was x, that one was x. You can't pull that out as a common factor because that's not the same thing. So I'm going to pull out sine x now as a common factor because when we expanded this, created a sine x, right? So when I pull out sine x as a common factor, I'm left with 2 cos squared x in this term. I'm left with plus cos 2x plus 1. This is all over cos 2x plus 1. Okay, this I'm now going to change. I'm going to change it into something that's going to cancel out this 1. So it's going to give me sine x into 2 cos squared x. I just brought that down. This one I'm going to change into something that's going to cancel out the 1. So I'm going to change it into plus 2 cos squared x minus 1. That becomes that. right? And then bring down the plus 1 at the end. This is all over cos 2x plus 1, right? This and this is gone. That then gives me sine x into 4 cos squared x. I'm going to now change this also into something that's going to cancel out that one. It's going to give me 2 cos squared x minus 1. This becomes this, and bring down the plus 1 at the end. Right? This is gone. And now what's going to happen is you left with sine x into 4 cos squared x all over 2 cos squared x. And because everything is being multiplied, that and that can cancel. 4 over 2 is 2. I'm going to put it in front, and the only thing that's left is sine x. And so this question said, simplify all of that to a single trigonometric ratio, and we were left with one single trigonometric ratio. And that's how you do that one. Right, question 6. It says, in the diagram, the graphs of f of x is equal to 2 sine 2x and g of x is equal to minus cos x plus 45 are drawn for the interval between 0 to 180. A is a set of coordinates that lies on f. It's 105 and minus 1. Write down the period of f. The period of a sine or cos graph is 360 divided by the coefficient of x, meaning b. So 360 divided by 2. Gives you 180 degrees. Right. Determine the range of G within the interval between 0 to 180. So the highest to the lowest point that G reaches within this interval. So the highest point it's going to reach is whatever G's amplitude is, and G's amplitude is 1. So the highest point it reaches is 1, but the lowest point it reaches is not -1. It is if the graph was drawn longer than 180. Like if it was drawn to 360, you would see that -1. But within the interval between 0 to 180, the lowest point that G reaches is this point, and that's not at -1. So I need to figure out what that point is. And to get it, it's pretty simple. This is the y-intercept of G. And so I'm going to make x equal to 0 in order to find what that point is. So I'm going to go make x equal to 0. That's minus cos into 0 plus 45. It gives me no clue. Minus cos 0 plus 45. Negative 2 the root of 2. Oh, it's a special case. I should have known that. But anyways, this is minus the root of 2 over 2. And so the highest point that this graph reaches is 1. Sorry. And the lowest point that it reaches within this interval is, the highest point it reaches is 1, and the lowest point it reaches is minus the root of 2 over 2. And how do we write that as a range? Smaller number first, bigger number next, y in the middle, that way. Equal to, because it does touch both of them. Okay, that's that one. Then we have, determine the values of x in the interval between 0 to 180 for which f of x times g of x is greater than 0. Greater than 0 meaning positive. This is the one where you label the graphs with positives and negatives, meaning wherever the graphs lie above the x-axis, you're going to label it positive. Wherever it lies below the x-axis, you're going to label it negative. So if I'm looking at f of x, this is where it's positive. Where it lies above the x-axis, that's where it's positive, and then it changes to negative wherever it lies below the x-axis. So whenever you have this question of something, two things being multiplied, you have to label it, right? This is negative here where it's below, and that's positive where it's above. And then I want you to highlight the points where the graph's signs change. So the pink, if you're just looking at the pink markings, the signs change here from positive to negative, and I'm going to draw a line on that. And that line is 90, x is equal to 90, right? That's where the pink graph sign changes from positives to negatives. And then I'm going to look at the blue graphs signs, and it changes here at 45. It changes from negative to positive, and that line is x is equal to 45. And now the question says we want something times something to give us a positive. Either a positive times a positive or a negative times a negative. So you need to look within these zones for either two positives or two negatives. In the first zone, one is positive, one is negative. That's not a solution. In the second zone, they're both positive. That's a solution. And in the third zone, one is positive, one is negative. That's not a solution. So my solution lies between 45 and 90. How do I write that? I go 45, smaller number first, bigger number next, 90, x in the middle. The question says for which values of x face the margin, right? No equal to if the question didn't have an equal to, which it didn't. The inequality here doesn't have an equal to, so you won't put an equal to in the solution. And that's that question, right? 6.3.2 says, where is f of x plus 1 less than or equal to 0? Whenever you get this, take the 1 over. That loose number, take it over. You can have f of x is less than or equal to minus 1. So this is what I want you to do. Completely different set of theory here. It's saying there's a line y is equal to minus 1. Draw that line first. I told you about this theory, right? You're going to draw the line on minus 1. Right. So this is the line y is equal to minus 1. This line, that's the line y is equal to minus 1. The question is asking, where is f of x? The graph of f? Below. Less than is below minus 1. The minus 1 line. Where is f of x? The graph below minus 1. So it's below minus 1. Sorry. F of x is this graph, by the way. It's below minus 1 from here to there. And so I need to figure out what those x values are. And so I have the 1, it's 105. I need to figure out what this x value is. I know this one is 105. Remember, this question starts for which values of x. So I'm only interested in the x value. And either way, the corresponding y is going to be minus 1 because it's on the line out. Y is equal to minus 1. But I know that this x value is 105. I need to figure out what this x value is. Now, because there's a turning point here, that means that this distance and this distance is exactly the same. So from 105 to 135 will be the same from 135 to whatever this is. So let's figure out what's that distance. From 135 to 105, from this point to this point, right? That distance is 135 minus 105. 135 minus 105 gives you 30. And so the same thing here on the other side. That means 135 plus 30 will give me whatever this x value is. And that gives me 165 and minus 1. All right? So 135 plus 30. Again, tell me why I'm doing that. The reason is because the difference between, hold on, the difference between this middle line of the turning point, this as the turning point, from the turning point to this set of coordinates must be the same from the turning point to that set of coordinates, because this line will cut the, that little part in half, right? Okay, so this is 165 and minus 1. All right, so where does it lie below minus 1? From 105 to 165. How do we write that? 105, 165, x in the middle, face the margin, put an equal to because the question had an equal to. Okay? We're only careful when there's asymptotes, and there's no asymptotes in a sine of cos graph. All right, that was 6.3.2. The next question says, hold on, I just want to take all of this out. Oh my. Oh dear. Okay. This was 165 and minus 1. Okay. The next question says, another graph P is defined as P of x is equal to minus f of x, which means the sign of y, because f of x stands for y, the sign of y was changed for f of x. And when you change the sign of y, it means that you deflected the graph across the x-axis. So the sign of y was changed, you deflected the graph across the x-axis. So that means that this graph is now going to look like this. Like that. Give me 1 second. Okay, so as I was saying, they said another graph P is defined as P of x is equal to minus f of x, which I told you means that the graph f was deflected across the x-axis because the sign of y was changed. Now they're saying D lies on P, but D's y coordinate is at -1. Right? Determine the values of k in the interval between 0 and 180 that basically have a y coordinate of -1. That's what they're asking you. Determine the values of k in the interval that's drawn where the x values have a corresponding y value to be -1. And so it's going to automatically be this point and this point, but it's reflected, right? So it's this point, it's in line here, and it's in line there. And so you need to figure out what those values are. So here's the thing. I know that their corresponding y coordinates for both of these is -1. I need to figure out what the x coordinate is. So the first thing I know is that this line, x is equal to 90, exists in both, right? And so what I'm going to do is I'm going to see what the distance from this 90 to this x value is. Because that would mean it's the same distance there, right? So the distance from 90 to 105 is 15. So this distance is 15, which means this distance is 15. So 90 minus 15 will give me this value, this x value. So 90 minus 15 is 75. That's the first one. Now, if that's 75, then the same way I found this 165 when I did the turning points x coordinate here, the same way I found this 165, I'm going to find this x coordinate, right? And this is how. So I know that this is 75, right? And so if this is the turning point of this part, I know that it's going to cut this part in half, right? And so if it cuts it in half, the distance from there to there, which is 45 to 75, 45 to 75, this is 75, right? This distance must be the same as this distance. And so it was 30 there, so this is also 30. From 45 to 75 is 30. And so from 45 to this x value must also be 30. So 45 minus 30 gives me 15. And so your values of k is equal to this 15, which has a corresponding y of -1, and 75, which has a corresponding y of -1. So k is 15 or k is 75. All right. I hope that made sense to you. All right. And then the last question here says, graph H is obtained when G is translated 45 units to the, or 45 degrees to the left. Determine the equation of H, right? So I'm going to take G of X's equation, which is y is equal to minus cos X plus 45 minus cos X plus 45. And they are saying that H is obtained when we take this G and translate it 45 units to the left. 45 units to the left simply means add 45 to X and then bring this one down also. So this is plus 45 plus 45. This is plus 45 because of this transformation, and this plus 45 is from G of X's equation. Right. Then that leaves me with minus cos. This is x plus 90. Or I'm going to write it as 90 plus x because I like the number in front when we're doing reduction, because this is going to be a reduction. And a reduction in the 90 plus quadrant. This is the 90 plus quadrant, right? Cos is negative in this quadrant. This is sine's quadrant. Cos is negative in this quadrant, so negative reduction from this quadrant times this negative times this negative is a positive. And because you're reducing with 90, that gives you a positive sine x. All right, so that is h of x's equation. Okay. Question 7. In the diagram, S, T, and K lie in the same horizontal plane. RS is a vertical tower. The angle of depression from R to K is beta. TSK is alpha. TS is P meters. And the area of triangle, the area of triangle STK is Q meters squared. Determine the length of SK in terms of P, Q, and A. Okay, so I'm just going to put in the information they gave me. They said TSK is alpha, that's in. TS is P, that's in. The area of this triangle is Q meters squared. Right. So I'm going to use that area in order to calculate this answer. You see, when you're using the area rule, you need two sides and its included angle. So for the area rule on this triangle, I need two sides and its included angle to get the area. But now I have the area, so I'm still going to use the area rule. And this is what I'm going to do. I'm going to say the area of triangle STK is equal to a half into the two sides, this one and this one, the sine of its included angle. That's the formula. So a half into ST into SK, the sine of its included angle, which is alpha. So again, for area, when they're talking about area, its formula or the rule, I hope you know it, is a half into two sides, the sine of those two sides included angle. All right. So this is these are the two sides that they're talking about, right? But now I have this because they gave it to me in the information. It's Q. It's equal to a half into ST, they told me is P. SK is what I'm looking for. And sine of alpha is sine of alpha. There's nothing I can do. Now, I want the length of SK in terms of P, Q, and alpha. And so it's very simple. All we're going to do is we're going to manipulate that equation so that SK is alone on one side of the equals to sign. So the first thing I'm going to do is I'm going to times both sides by 2, just so that I can get rid of this a half. So this is 2Q is equal to P into SK sine of alpha. And then I'm going to divide both sides by what I don't want, which is P sine alpha, P sine alpha. That and that's gone, that and that's gone. So you're left with SK is equal to 2Q over P sine alpha. And so here I'm going to put it on my diagram. 2Q over P sine alpha. All right. Okay. That's that one. Remember, you can use the area rule to find a side or an angle as long as you are given the area. All right. Okay. Show that RS is this whole drama. Okay. First of all, they told me that the angle of depression from R to K is beta. So this is the angle of depression, which means that this line and this line is parallel. There's an angle of depression comes from a horizontal, and this is a horizontal on the ground. This has to be a horizontal for this beta to be an angle of depression. And so it's parallel to the ground because it's a horizontal line, right? And so if it's parallel to the ground, then that means that angle RKS is also beta because of alternate angles. I'm going to call that RKS is equal to beta. Reason, alternate angles. So this is beta. Okay, pause. Okay, so as I was saying, RKS will be beta because of alternate angles. And now the question's asking us to show that RS, oh my, okay, RS is equal to all of that drama. So RS in terms of this angle, beta, RS is opposite, right? And we're working in a right angle triangle. So we can use trig ratios. So RS is opposite and the side that we have is adjacent. So what you want is opposite, what you have is adjacent, and the function involving what you want and what you have is tan. So we're going to go tan beta is equal to opposite, which is RS, over adjacent, which is 2Q over P sine alpha. Right, and then this is over 1. We're going to cross multiply. That times that is equal to that times that. So RS is equal to 2Q tan beta all over P sine alpha, which is what they asked us to prove. All right, that was that one. Then it says calculate the size of alpha. If alpha is an acute angle, less than 90, RS is 70, P is 80, Q is 2,500 meters squared, and beta is 42. So I'm going to take this equation and I'm going to sub in all the values, right? RS is 70 to, sorry, to Q. Q is 2,500. Tan beta is 42. All over P, which is 80, sine alpha, which is what I'm looking for. Right. And then at this point, I just need to manipulate this in order to solve for sine alpha. So the first thing I'm going to do is I'm going to take this 80 up. Oh dear. Hold on. Right. So 70 times 80, that gives me a 5600 on this side. 2 times 2,500 is 5,000 on there. That's tan 42 all over sine alpha. Remember, I just took that times that to get this, right? Okay. And then I'm going to shift this up, shift that down. All right, remember you can do that as long as you're moving numerator to denominator and denominator to numerator. So I'm going to have sine alpha here is equal to 5,000 tan 42 all over 5600. And then to get alpha, you have to shift sine this whole drama. And then that will give you an answer of, hold on, 53,51. Done. All right. Okay, not doing proofs. Go and learn your proofs. Okay. In the diagram, O is the center of the circle and ABCD is a cyclic quadrilateral. OB and OD are drawn. If O1 is equal to 4x plus 100, let's put that in. O1 is 4x plus 100 and C is x plus 34. Calculate, giving reasons, the size of x. So the first thing is I'm going to go with angle A. Angle A is equal to half of O1. And the reason is angle at center equal 2 times angle at circumference. All the drama. Okay, so it's a half of 4x plus 100. So as I was saying, this angle is 2 times this angle, right? Okay, so that gives me 2x plus 50. So that's angle A, right? And so now this is 2x plus 50. And to get the value of angle x, I'm going to say that this plus this is equal to 180 because they are opposite angles of a cyclic quad. This is the cyclic quad, ABCD. Opposite angles of that cyclic quad are supplementary, meaning they have to add up to 180, which means angle A plus angle C must give me 180, and you have to give a reason whenever you're dealing with Euclidean geometry. Opposite angles of a cyclic quad are supplementary, right? So we're going 2x plus 50 plus x plus 34 must be equal to 180. That gives me 2x plus x is 3x. 180 minus 50 is 130, minus 34 is 96, I think it is. Divide both sides by 3, x is equal to 32. Let me just double check that. It is. Okay, and that's your 5 marks. All right, okay. In the diagram, O is the center of the larger circle. OB is a diameter of the smaller circle. I'm going to stop. When I say OB is the diameter of the smaller circle, immediately I know that if this is the diameter subtends a 90-degree angle at the circumference. So I know that OMB is 90. And I'm going to make the statement the second I put it in my diagram. OMB is equal to 90. And your reason is angles in a semicircle. Right, so that's 90. Chord AB of the larger circle intersects the smaller circle at M and B. Write down the size of OMB, provide a reason. Okay, it's done. Right? Then it says if AB is equal to the root of 300 and OM is 5. AB's whole distance is the root of 300 and OM is 5. Calculate giving reasons the length of OB. So first of all, I'm going to make the statement that AM is equal to MB. And this is the first theorem in grade 11. AM is equal to MB because there's a line from the center of the big circle to perpendicular to the chord. Perpendicular to the chord. So what am I talking about? There's a line drawn from the center of the circle, the big circle, perpendicular to a chord. It will bisect that chord. That's the theorem, right? The line drawn from the center of the circle perpendicular to a chord will bisect the chord, which means that MB is equal to half of AB, which is half of the root of 300. MB, this, is half of this whole distance, right? And so it's half of the root of 300. I'm going to leave it as that, or we can just write it as the root of 300 over 2. Right, so this is the root of 300 over 2. Right, then in triangle OMB, I can calculate the length of OB using the theorem of Pythagoras. I'm going to go OB squared is equal to 5 squared plus the root of 300 over 2 squared. I'm not going to forget my reason. It's Pythagoras, right? That gives me OB squared is equal to 5 squared is 25. No idea what that is. 300 over 4. Okay, hold on. 75. Right, that gives me OB squared is equal to 100 square root, don't forget your plus minus, but we know OB is a length, so it's going to be a positive 10. And that's that one. Okay, question 9. In the diagram, ABCD is a parallelogram with AB equal to 14. AD is produced to E such that AD is to DE as 4 is to 3. AD is to DE as 4. I'm going to put a variable to show it's a ratio. 4 is to 3, which makes this whole thing 7K. Right. EB intersects DC in F. EB is 21 units. Okay. Calculate with reasons the length of FB. So they gave me that EB is 21 units. Right. But first of all, I have a set of parallel lines here. This line and this line is parallel within this triangle, which means I can use proportionality on the other side of that triangle. So what I'm going to do is I'm going to say that just like AD is to DE as 4 is to 3, I'm going to do the same thing. I'm going to say that FB over FE is 4. I'm going to change the variable there to show you dealing with a different side, is to 3, which makes the whole thing ratio-wise 7A. Length-wise, that whole length, EB, is 21, but ratio-wise, that whole length, that whole side is 7A. I'm going to say that one more time. EB, when you're thinking about it in terms of length, is 21. But if you're thinking about it in terms of a ratio, it's 7A. I'm going to make that statement first. I'm going to say FB over FE is the same as AD over DE, which means that it's the same as 4 over 3. Right, you made a statement here, you have to give a reason. The reason for proportionality, you can use prop theorem, right, and mention the parallel lines, otherwise you don't get the mark. DF parallel to AB, or the safer option, according to me, is line parallel to one side of triangle. Line parallel to one side of triangle. This is the proper reason for proportionality theorem. Okay, so we had to make that statement first, right? Before we can calculate FB. Now, looking at FB, FB is the length that I want. This is what I want on this side of the triangle, right? So on this side of the triangle, I want this. I have this length. So this is the length I want. This is the length I have. So I'm going to make a statement of what I want over what I have. What I want is FB. What I have is EB. And then I'm going to make it equal to its ratio. What I want ratio is 4A. This is what I want. Its ratio is 4A. And what I have's ratio is 7A. Ratio on the other side, right? That's 7A, right? And then you're going to fill in FB is what we're looking for, sorry, over EB is 21. These A's cancel, so you're left with 4 over 7. And then you cross multiply and you solve for FB. FB is equal to 4 into 21 all over 7. That goes there once, that goes there 3 times. 3 times 4 is 12. Or you just put the whole thing in on the calculator. So FB is equal to 12. All right, so FB is 12. I'm going to take this out. I'm going to put this in. That's 12 units, which automatically makes EF 21 minus 12. I hope that makes sense. Hold on. Okay, 21 minus 12, which gives me this to be 9 units. All right. Let's take out all of this. Okay, 9.2 says, prove with reasons that triangle EDF is similar to triangle EAB. EDF, I'm going to highlight them, right? Wait 1 second. Let's just put this thing on charge. Okay. Right, so we need to prove with reasons that triangle EDF, which is this one, hold on, which is this one, is similar to triangle EAB, which is this one. Right, so to prove similarity, the first thing I'm going to do is in triangle EDF and triangle EAB, right? Angle E is equal to angle E common. Right, so that angle is equal to that angle. It exists in both. And then I'm going to make the statement that this angle in the blue is equal to this angle in the orange because of corresponding angles. Those are corresponding angles. They are equal. So I'm saying F is equal to B. So angle F is equal to angle B. Corresponding angles And the parallel lines are FD parallel to AB. And then the last remaining in the blue triangle is D. You'll see that I put blue, 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 right? That's the last remaining in the blue. And the last remaining in orange, you'll see that that's orange, orange. And the last one has to be orange. So the last one remaining in the orange is angle A. And again, corresponding angles also, because these are also corresponding angles within the F. Those are corresponding angles that are equal. So you can give that reason, or you can say interior angles of a triangle. Sum, or whatever, angles in a triangle, whatever it may be, right? And then you say, therefore, EFD triangle is similar to triangle EBA, and label it downwards. EFD and EBA. It has to be labeled like that. You don't have a choice. And then the reason here at the end is angle, angle, angle. Just make sure that all the blue triangles, angles are on one side, and all the orange triangles, angles are on the other side. And when you label the first one, this one must be labeled exactly the same as the first one, right? Angle wise. So you can't have EFD on one side and then swap these around. You can't do that, right? Otherwise, your future calculations are going to be a problem. Okay. Future calculations within the sum, I mean. All right, okay. Right. That last reason, by the way, of angle, angle, angle is very important, right? This last reason of angle, 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 very important. You need to put it in, you get a mark for it. Right, okay. Calculate with reasons the length of FC, right? I want you to see that generally after they ask you to prove two triangles similar, they'll ask you a question based off of those similar triangles. So I'm going to pull the triangles that are similar. It's EDF and EAB. They are asking me for the length of FC, right? So if you're looking at FC, it's this side, right? But I know that this entire length, this distance, is 14, because this is a parallelogram, and so I know opposite sides of a parallelogram are 14. If this is 14, then that whole side must be 14. Now they are asking me for just this part. Now I don't have enough information to get that part. I don't have enough information in that triangle to get that part. However, I can get this part, which is FD, right? So this is what I'm going to do. If I get FD, I can say that FC is 14, which is the whole thing, minus FD. So this is what I'm going to do. I'm going to get FD first. All right, I'm going to get length of FD first. And so when I look at my similarity, I'm going to arc FD. It's these two. And so when I arc here, it has to also be the last two. I don't have a choice there. And then I'm going to look for a side that I have in this triangle, because this is what I want. All right? And the side that I have is EB. EB. I know that it's 21. And so if I have EB, I also have to arc EF, the first and the last. EB is the first and the last here. That means you have to arc the first and the last there. That's a side that I have. You also have EF here. All right, okay. So here's what we're going to do. I want FD. So I'm going to start with what I want. FD over this one over this one. FD over EF. And so if I went small arc, the bottom over the top, on the other side, I also have to do bottom over the top, which is AB over EB. All right? And this is similar triangles. That's your reason. All right. So we went what I want over what I have, and is equal to, on the other side, we went bottom over top just like you did bottom over top, right? And so when we're filling in, FD is what I'm looking for. EF, let's look at it. EF was this 9. AB, they told me is 14. EB, we said is 21, this whole distance. And so the only thing I'm looking for there is FD. So that's no idea. It is 8. No, it's 6. FD is 6. Right? So FD is 6 units. Right. So remember, I get this by saying 14 times 9. Right? Divide that by 21. And it gives you an answer of 6. But remember, this question asked me for FC. Now, FC, I told you, is this whole distance minus this distance. So it's 14 minus FD that I just calculated, which is this distance, which is 6. So FC is equal to 14 minus 6, which gives me 8. And that was that one. This is quite simple, actually. Okay. Question 10, and hopefully the last question. Oh, thank goodness. Okay. In the diagram, PQRS is a cyclic quadrilateral such that PQ is equal to PR. PQ is equal to PR. The tangents to the circle through P and R meet QS produced at A. QS produced at A. Got it. RS is produced to meet tangent AP at B. RS is produced to meet AP, which is a tangent at B. Got it. PS is produced to meet the tangent AR at C. Got it. And PR and QS intersect at M. Okay. Prove giving reasons that S3 is equal to S4. Okay, there's no way you're going to do this question without making something X. And the thing that you need to make X is one of the angles that they are asking you to prove equal. So either make this X or this X. I'm going to go with S4. No, I'm going to go with S3. I'm going to say let angle S3 equal to X. No, let's go S4. Sorry. Chopping and changing depending on, right? I'm doing S4 because I know it exists within a bow tie butterfly. That's why, because I can extend this angle further. Okay, that's why I'm going with S4. So I'm going to say let S4 equal to X. So this is X. Automatically, then I know that S1 is equal to S4, which is equal to X, because they are vertically opposite angles. So this is X. I'm just extending it as far as I can. I said also that angle R3, angle R3 is equal to angle S4, which is equal to X, because same segment, angles in the same segment. So again, I'm going to show you that. The bow tie butterfly, this S4 and R3, they are equal. All right, so this is X. I forgot what I was proving. Oh, S3. Okay. What else? Okay. This side and this side are equal. They told us that in the information. PQ and PR are equal. Which, if this is the triangle, and this side is equal, then automatically that angle and that angle is equal because of angles opposite equal sides. So Q1 and Q2 is equal to angle R3, which is equal to X. So I'm going to make that statement that Q1 plus Q2 is equal to angle R3, which is equal to X, because of angles opposite equal sides. Right, which means this whole angle is X. Right. And then I'm going R1 and R2. R1 and R2. Hold on. I just want to see where that comes from. Okay, I'm not doing that. We're going cyclic quad. Right? So this and S3, remember S3 is actually what I wanted to be X, right? Because I'm trying to prove S3 and S4 are equal. And I started by saying S4 is equal to X. So I'm also trying to prove that S3 is X. And so I did, sorry, I did that right now because S3 is the exterior angle of this cyclic quad. So the exterior angle of the cyclic quad is equal to the opposite interior angle. And so now I can make the statement and say that angle S3 is equal to Q1 plus Q2, and Q1 plus Q2 is both. Together they are X, and this is exterior angle of cyclic quad. And so therefore, S4 is equal to S3 because they are both X. Proven. All right, so this is X. Okay, I hope that made sense. All right. Prove giving reasons that SMRC is a cyclic quad. SMRC. I'm going to highlight that. SMRC. That one is a cyclic quad. Okay, this one I can see pretty clearly. I don't know if you guys can see it because there is a lot going on in this diagram, honestly. But I'm going to use my tangents, right? This angle is subtended from chord RP. Chord RP. Right? So angle Q, the whole of angle Q, is subtended from chord RP. And chord RP meets this tangent. Right? It also meets this tangent, but there's not enough information there. Well, there is. But I'm going with this tangent. Right? And so if it meets that tangent, then this angle between this tangent and this chord, the angle between the tangent and the chord is equal to that angle that the chord subtends in the opposite segment. So this angle and this angle is equal. And we know this whole angle is X. So R1 plus R2 is equal to Q1 plus Q2, which is equal to X. R1 plus R2 is equal to Q1 plus Q2, which is equal to X. Tan chord theorem. Right? So I'm going to make the statement and I'm going to say angle R1 plus angle R2 is equal to angle Q1 plus Q2, which is equal to X. And your reason is tan chord. So this whole angle is X. And so remember that the question that they asked me to prove is, prove SMRC is a cyclic quad. And I should have mentioned this in the start. To prove a cyclic quad, there is only one of three ways. Right? It's either the bow tie butterfly, or it's proving the sum of opposite interior angles are supplementary, right? Or it's proving that the exterior angle is equal to the opposite interior. One of these three ways is how you prove something is a cyclic quad. And so now if I'm looking at my cyclic quad, wait, I'll move this down, hold on. If I'm looking at the cyclic quad they're asking me to prove, they're asking me to prove this cyclic quad. SMRC, SMRC. I'm going to extend that arm. Here's an exterior angle of the cyclic quad. It's equal to the opposite interior because they are both X. S4 is X and R1 and R is X. We proved that. So I'm going to say after we said this statement, I'm going to say that R1 plus R2 is now equal to S4, which is equal to X, proven, because they're both X, so they're equal, right? If they're both equal to X, that means they are equal to each other. And so therefore, what did they say? SMRC is a cyclic quad, and your reason is converse. This word is very important when you are proving something is a cyclic quad. You have to use the word converse of exterior angle of cyclic quad. I just want to see if they accept anything else. No. It has to be converse of exterior angle of a cyclic quad. All right. That was that one. Okay, give me a second. Okay, so this last question says, 10.3, RP is a tangent, proved giving reasons that RP is a tangent to the circle passing through P, S, and A at P. RP is a tangent to the circle. First, we're going to sketch in the circle. Here's the circle. The circle passes through P, S, and A. P, S, and A, like that. RP, we need to prove, is a tangent to the circle at P. Right, okay, so that's the line we need to prove is a tangent to the circle that passes through P, S, and A. And so to prove a tangent, you can either prove tan perpendicular to radius, you can prove two tans from same point, or you can prove the most common one, which is tan chord. You can prove that the angle between the supposed tangent and a chord is equal to the angle that that chord subtends in the opposite segment. What do I mean? I mean, in order to prove that this yellow line is a tangent, this chord that's within this blue circle, I have to prove that the angle between that tangent and that chord is equal to the angle that that chord will subtend in the opposite segment. So that means in order to prove that RP is a tangent, I have to prove that this angle between the tangent and this chord of the circle, the angle between the tangent and the chord, is equal to the angle that the chord subtends in the opposite segment. So basically, I need to prove that P2 is equal to A2. That's what I need to prove. And so again, just like this, where I needed to make one thing a variable, I'm going to do the same thing. I am proving two angles equal. I'm going to make one of them y, because I already have x's on this diagram. So I'm going to say let P2, angle P2, equal to y. Right? So this angle P2 is y. Then I'm going to try and extend that y as far as possible. So let's say I have y there. This is a bow tie butterfly. Right? Which means Q1 and P2 is both y because of same segment. So I'm going to say that angle Q1 is equal to angle P2, which is equal to y. And the reason is same segment. Right. So angle Q1 is y. Right? Which automatically makes angle Q2 x minus y. The whole thing minus that thing will give me just this part. Right? The whole angle x minus just this part will give me this part. That's why I'm saying x minus y will give me x minus y. Right? So Q2, I'm going to write the statement here. On the side, I'm going to say Q2 is equal to x minus y. No reason, it's just sheer logic, right? Okay, so that's Q2. That's Q2. Okay, I can extend that to R2 as well. But do I need it? Hold on. I do need it. Okay, so I'm going to extend that to R2. I'm going to say R2 is equal to Q2, same segment, which is equal to X minus Y. This reason is same segment. I'm going to show you the bow tie now. Same segment. So R2 and Q2. Those two angles are equal because of the bow tie, right? So R2 is also equal to X minus Y. So I'm going to put in here that R2 is X. Oopsies. This is X minus Y. Okay. But then I'm also going to say that P1 is equal to R2. Let me just check that again. P1 is equal to X minus Y. Yes. Okay. Let me remove all of this for you in order to see that. All right. P1, which is this angle, it's between a tangent and this chord. And that tangent and that chord will subtend R2. And so P1 is also X minus Y. And the reason I'm finding P1 is I'm just trying to get the angles closer and closer to A2, because this is what I'm looking for. So I'm trying to get angles that get closer and closer to A2. And so I said P1 is equal to R2 because of tan chord. Again, I'm going to show you that. P1 and R2. Hello, someone show me that. Okay, never mind. Okay, so P1 and R2 are equal because of tan chord. I'm just showing it to you. Yeah. So this is going to be this. P1 is an angle between a tangent and a chord, and that chord subtends R2. So R2 and P1 are equal, tan chord. So I have that P1 is equal to R2, which is X minus Y. And your reason here is tan slash chord. Okay. So I'm going to put in P1 as X minus Y. Right. And now it's very simple for me to see this part. This is the exterior angle of a triangle, of this triangle. Exterior angle of this triangle is this. That angle must be equal to the sum of the opposite two interior. So that plus that must give me that, right? That's the exterior angle of the triangle. And the exterior angle is an X. Right? It was S4. S4 is X. Let me just put that in. Sorry, I know this one was hectic, but you just have to use everything at your disposal. And as long as you're using the correct theorems, you can manipulate your X's and Y's wherever you can. You didn't have to do it this way, but whatever it takes, right? I'm saying here that P1, this angle, plus this angle, A2, must give me S4 because of exterior angle of a triangle. So that's the statement I'm going to make. And I need to bring A2 into it anyways. So I'm going to say that A2 plus P1 must be equal to S4 because of exterior angle of triangle. And so A2 is what I'm looking for. P1 is X minus Y is equal to S4, which is X. And so I'm going to take both over. It's going to give me A2 is equal to X minus X plus Y. That cancels. A2 is equal to Y. And remember, that's what I was trying to prove the entire time. I was trying to prove the entire time that A2 is Y, because then that means that P2 and A2 are equal, and that's the angle between a tangent and a chord is equal to the angle that the chord subtends in the opposite segment, which makes RP a tangent. So I'm going to say, therefore, this is how I'm going to end. I'm going to say, therefore, P2, the same one that I started off saying, let it equal to Y, is equal to A2 because they both Y. And my reason is proven because I proved them both Y, so that's how they are equal. And then I'm going to end by saying, therefore, RP is a tangent. And the reason, again, when you are proving a tangent or a cyclic quad is very important. Not when a cyclic quad or tangent is given to you, but when they ask you to prove something is a tangent or a cyclic quad, your reason must start with converse of whatever theorem that you proved. Converse of tan chord theorem. And that's that. Okay, that paper was lovely. So I'm hoping that you get a paper similar to the level of this 2023 because it was a joke. All right, but good luck.